Okay, hello everyone, and thank you for being here. Thank you for joining us today for this webinar presentation on emergency lighting. My name is John Levy, and I'll be moderating this session along with my colleague and your presenter today, Garth Stevens. In this presentation, Garth is going to analyze various methods for supplying backup power for emergency lighting, including battery packs, battery systems, and generator systems. And he's going to help us unpack and think through the National Electric Code sections 700.16 and 17. But before I turn the mic over to Garth, I do want to just get over to the next slide and share a few housekeeping items. First, like I say, we appreciate you being here. Thank you. If you are interested in getting the slide deck of this presentation, you can visit our website and go to the Insights menu at the top of the page. If you're an engineer, this session may meet requirements for PDHs depending on your professional registration and or certification requirements. We would be very happy to provide you with a participation certificate if that would be useful to you. Just email us hello@m-m.net. I do want to say just a quick word about Morrison-Maierle. We are a 100% employee-owned, multidiscipline engineering consultant with offices throughout Montana, Oregon, Washington, Wyoming, and we would be thrilled to keep in touch with you on our social media sites, or you can sign up for our newsletter, which you can get also on our website. If you have any questions today for Garth, please use the Q&A feature in the upper menu of this webinar. And you just go ahead and click that icon, type in your question, and we'll make sure to get to it before we conclude for the day. One last note here. Let's meet Garth. Garth Stevens, my colleague, is a senior electrical engineer with Morrison-Maierle with over 37 years of experience. He has worked on a range of projects over this career, spanning many use types, including commercial, residential, educational, healthcare, and many more. He's also authored a white paper on this same subject. If you're interested in that, you can also get that from our website as well. And with that said, I think I'll turn it over to Garth. So Garth, take it away.
Thank you, John. Man, it was nice to hear all those nice things about me. Don't you have anything else? Come on, let's keep going. Anyway, all levity aside, I just want to give you a little more background on how I came to this topic. Basically, I originally really wrestled with these sections in the NEC and struggled and thought about them a lot and woke up in the middle of the night thinking about them and just really struggled. But as I finally came to understand them better, it did make more and more sense to me, and I got more and more excited about it. And I know sometimes we think that, well, emergency lighting, that's just a small part of what we do. But it's exciting to me, and it's important and exciting. And so I appreciate you being here and going through this topic with me. And so I wish you all a good afternoon or morning, depending on the time zone you're in. And here we go. So suddenly my deck's not working. Okay. So first of all, we'll talk about what we're doing here and what our goals are. First, we'll talk about why we have emergency lighting and why it's important. We'll talk about some of the applicable codes that drive emergency lighting. And then we'll talk about various ways to accomplish emergency lighting with discrete fixtures, commonly known as bug eyes, or with battery packs on normal fixtures, with central inverters, and with on-site generators. And then ultimately, kind of as we go through this discussion, we'll talk about how these emergency lights ultimately help in protecting lives and help all of us as we go through things. So there are only so many hours of daylight in any given day, and we're all kind of coming out of winter here. And I noticed it is getting a light a little bit earlier and staying light just a little bit later. That's exciting. But basically, we all have to deal with darkness every day. In our early ancestors, they had to worry about nocturnal predators and things that go bump in the night and scary stuff. And so basically, they would find some safe, relatively comfortable place and wait it out until sunrise. Then for centuries, we used fire to produce light, and including candles and torches and ultimately fixed gas lighting. And then in the early 1800s, electrical lighting started to become feasible and common, and now it's everywhere. And so because of this artificial lighting, we've been able to extend our day, which is a good and a bad thing. It's great to be able to finish up what you're doing, but at the same time, a lot of us end up burning the midnight oil and not getting the rest that we probably should. That's neither here nor there, but anyway, so the important thing with emergency lighting is egress lighting and helping people get out of the building. And the reasons for this is the building may be unsafe. There may be a fire in the building. The building may have suffered structural damage or other problems, and it's not safe to be in the building. Also, if you're a visitor in a building, you may not be familiar with the paths of egress. Also, in complete darkness, it's very easy to get disoriented, even if you are familiar with the building. And so we need to light the path so that people can find their way out. And finally, even if it is an area that you know well, maybe you work there, when the power goes out, you may as well go home. Why stick around? You can't do anything. And so you want to be able to get out of the building. So you say, yes, but I have a flashlight in my pocket. And cell phones are a wonderful thing. Most all of us carry them, spend more time on them than we should. I know I do. But can we really depend on them? I mean, has anyone else ever lost their phone or left it on their desk when you go off to a meeting, or just flat out had the battery die? All those things have happened to me. And so I cannot always trust that I'll have that handy flashlight with me. And the code realizes this, or our code makers realize this. And so in the codes, emergency lighting is addressed. It's addressed in the International Building Code in section 1008. It's also addressed in the NFPA 101, the Life Safety Code. There are a number of paragraphs in there that discuss it. It's also addressed in NFPA 99, Healthcare Facility Code. The NFPA 110 covers emergency and standby power. And then finally, the one that a lot of us are the most familiar with, the National Electrical Code, Article 700, talks about emergency systems. Now, as we talk about these codes, building codes, electrical codes, different codes, I need to throw out a disclaimer. Number one, the codes are dynamic. They're living documents. They change from cycle to cycle. And so the things we discussed today, the next cycle or two, maybe some of the points will be irrelevant or will have changed. And so we have to keep up with the code that's being observed in whatever area we're working in. Next, the authority having jurisdiction is the one that has the final say. And this is called out right in the code in Article 90. And so sometimes that gets a little difficult to remember, because we might go on the internet or or I might think that I'm an authority about this thing, or we'll see things on the internet from those who proclaim to be authorities on these topics, but they don't have any jurisdiction. So they might really know their stuff, but that's not their jurisdiction. So we have to use that information that we find carefully. We can use those ideas to discuss these things with our authority having jurisdiction. But ultimately, that individual, he or she, will make the decision, and we need to comply. Finally, if there's something in the code that we just don't think is right, or we don't understand, or we have problems about, we can always request changes or express concerns to the appropriate code making panel. So basically, we're going to talk about IBC 1008 and Chapter 7 of the NFPA 101, and kind of lay down some of the requirements for emergency lighting. So the first one is the emergency lighting needs to come on within 10 seconds. Can't take any longer than that. The emergency illumination has to last for 90 minutes in the event of a failure of normal lighting. It has to have an average foot candles of 1 foot candle average, and not less than 0.1 foot candle anywhere measured along the path of egress at the floor level. And over the 90 minutes, the average illumination can decline from an average of 1 foot candle down to 0.65 or 0.65 lux. So the max to minimum illumination cannot exceed 40:1. So basically, you can't light a long hallway with one really bright light in the middle of the hall. You have to make sure that you've got even lighting throughout that path of egress. Another thing that the codes cover is maintenance of emergency lighting. And this comes from NFPA 110. Unfortunately, this really isn't covered in the IBC. Normally, from my experience, NFPA 110 is followed in healthcare facilities, and so they are inspected yearly. Whereas most buildings, at least around here, that get built, no one comes back a year later to look at them, or certainly not consistently. But the requirements for maintenance of your emergency lighting is that they need to be visually inspected every 30 days. And this visual inspection is important because there may be a change, maybe a partition was put up, or somebody's hanging their jacket over the emergency light or something, and therefore it's not going to do the job it needs to do. Also, every 30 days, we need to do a 30-second functional test. And annually, we need to do a 90-minute test to make sure that those batteries are being maintained and are up to snuff. And finally, written records need to be kept. Now, for all this testing, we can get fixtures that have self-test and self-diagnostic capabilities, and they can do that testing for us. But again, if we do that, we have to remember that we still need to visually inspect these lights on a regular basis so that we know that they're still going to light the area as needed. Also, if you've got a very large facility with a lot of emergency lights, you can get a computer-based testing system that will do those same things, test every 30 days and then once a year, and it will keep records for you. So that's a more expensive way to do it, but if you've got a large facility, it may well be worth it. Again, these testing and maintenance requirements really only come up in like hospitals or healthcare facilities, and a lot of buildings that just get built, office buildings and the like, unless there is a specific requirement within your jurisdiction, they don't really get looked at. And I'm familiar with at least 2 instances where the power went out, emergency lighting was needed, and it was not there because they had not been maintained. Okay, so basically we need to keep the path of egress lit. So let's dive in here a little bit into the NEC. First of all, we got system reliability, and basically what this is saying is that if you had like a single branch circuit serving a stairwell, and that circuit failed for whatever reason, the breaker tripped, or someone inadvertently turned that breaker off, that stairwell could then be left in total darkness, and we definitely don't want that. So we need at least 2 branch circuits from separate power sources for our egress stairwell, and that way it's unlikely that both circuits would fail simultaneously, and thus that reduces the risk of being in total darkness. All right, another portion then of the NEC, there are basically 2 ways to meet these requirements, and we can use either of these methods to meet this. The first method is in 700.17.1. Basically, it addresses luminaires with an integral backup, such as bug eye lights or luminaires with a battery pack on it. The second way then is to have 2 separate and complete systems with independent power sources. So this addresses like inverters or generator, where we've got 2 separate and independent power sources. The other thing it says about this portion is that if either system needs to be energized when the other one fails. So you got to have it set up so that it automatically comes on to the one that's still available. You're not left without light. Okay, so we'll start off talking about basic battery packs or bug eye lights. Number one, they're very recognizable. People are used to seeing these. They know what they look like. They know what they're supposed to do. And frankly, I have a hard time walking by one with the picture there on the left with the little lit button. I'm just drawn to push that button and make sure it works. So they're a little easier to keep maintained because they're obvious, and you just want to go test it. Also, these come on immediately if the power goes out. There's no real delay at all. They sense that normal power's gone and they come on immediately. One thing that we need to be careful with on these is when we have these kind of fixtures in a corridor, we need to make sure that they are on the same circuit as the other lighting in that corridor, the unswitched portion of that circuit. And that way, if somebody inadvertently turned off that breaker and the lights went out, these would come on right away. Now, the problem with these is often these don't meet the aesthetic. I mean, if you've got a industrial space, they're fine, but a lot of nice architectural areas, they just don't really look that nice. So the manufacturers have come up with some other ways to do this. One of them is a one that's flush, like in your ceiling or your wall, and then when the power is lost, they automatically come on. They swivel and pop on. And in fact, we've got one of these in one of our offices, and caught a little video of how they work. They come on. They do a nice job. One thing about this is you see on there that there are a couple little buttons to push, but it's not as obvious as those other ones. So you have to be careful when you put these in that you do go around and maintain them. Another option is to put a larger battery pack in, say, a mechanical room or a janitor closet, and then you can have remote heads like the one shown on the right there that don't stick out quite as much. They're not quite as hard to take as a bug eye in the hallway. So that would be these flush in the ceiling remote heads that would be lighting your hallway. Um, so and the next option then is to have integral battery packs in normal lights. And the beauty of these is they look the same. You can't really tell that they're an emergency light, except that there'll be a little lit button somewhere on the light or next to the light that allows you to test it and make sure that it's working right. These lights can be set up to be switched and controlled with the other lights in the area. But when power is lost, they will sense that and they will come on immediately. Again, these are a little harder to, I mean, they don't jump out at you like a bug eye when you go through for your walkthrough to maintain things. But they're very nice, and when they're maintained, they work well. If they're not maintained, they don't work so well. All right. So now when you've got a large facility, sometimes there are other options. Basically, I like to talk about this as an egg in a basket analogy. Basically, what we've talked about so far is having each egg in its own basket. So if we were to drop one of those baskets, if one of those batteries died or the fixture didn't work, we would lose that one light, and the others in that corridor or that area would still come on. We haven't lost them all. When you have a lot of eggs or a lot of emergency lights that you need, it does become easier to put them in a larger basket. It's easier to carry. The only thing is that you got to make sure you don't drop the basket because you can really have some trouble. So in talking about this, there are two different kinds of devices that allow us to do this, to make this work. And basically, when they're done right, they're set up so that if the entire building loses power, the lights come on. Or if that local circuit goes out, the lights come on. So to describe these, I have used some basic relay logic, and I know that this is old school and some of you might not even have encountered it. So I thought I'd run through it quickly. Those who have, I apologize, but basically the relay consists of a coil and at least one contact. And the contact is either normally open or normally closed. And it's always shown in this de-energized state. So you see on the left there, a normally open contact on top, and then it's on the right as well, the normally open, and then the normally closed below. You can see the symbol that's used. And basically, if a normally open contact, if the coil is de-energized, then it's going to be open. In fact, it's going to be like an open manual switch. Whereas a normally closed contact, if the coil is de-energized, will look like a closed switch. And vice versa. A normally closed or a normally open contact, when the coil is energized, will look like a closed switch, and a normally closed contact, when this coil is energized, will look like an open switch. And so as I go through this discussion, I'm showing this. You can see where we've got, like, the red is the energized portion of the circuit. And on that first one, the normally open contact, when it's de-energized, you see it hits that contact and it stops. It can't go on because it's an open switch. Whereas with the normally closed, it will go right through because the coil is de-energized. So, and just to drive this home, basically, if the coil is not energized, it's de-energized, then, and you've got a normally open contact in your circuit, then the light is not going to come on. It's not getting any power. Whereas if it's a normally closed contact and the coil is de-energized, the power will pass through and the light will be on. And then vice versa. If your coil is energized, that normally open contact will allow the power to pass through and the light will be on, whereas a normally closed contact then will be open and the light will be off. So basically, like I mentioned, there's two basic devices that are used to make this work when we have more than, when we have a lot of devices and a single power source. And so the first one is called an automatic load control relay. Basically, it allows for the power. It monitors the normal power, and if that power goes out, it forces that emergency light to come on at full brightness. And when there is power, it allows those lights to be dimmed or otherwise controlled along with the other devices in that area. And then it makes sure that we've got power to the light when the normal power goes out. So I've represented this again with my relay logic, and this is not how these are built, obviously. A relay is like an electromagnetic coil, and so this would be too big. As you notice that picture that we showed, they're pretty small. So they're done with microchips and things. But I use this relay logic just to represent how these work. And so you can see with this one, you've got basically like two coils in there, and then a number of contacts associated with those coils. And we'll go through how this works then. So if we've got normal power present, that's the blue, and if that power switch is closed, then the light, our emergency light, is going to be on, just like the other lights in that space. Whereas if the normal power again is present, but that switch is open, then the light will be off. It turns off. Also on this, you might notice that we've got the 0 to 10 volt control, because a lot of our lights are dimmed and different things now. So when the switch is closed and coil C2 is energized, then that contact would be closed and that signal would get to the fixture. Whereas when it's open, you wouldn't get that. Now, if we lose normal power, then C1 becomes de-energized, and so does C2. And so basically, through C1, that normally closed contact, it closes and allows the emergency power to get to our emergency luminaire, and we've got our emergency lighting. So these work pretty slick. One thing to note is that your emergency luminaire is connected to the emergency power circuit. So if you're laying out an area, you need to make sure you've got sufficient capacity on that emergency power circuit to handle these lights, because they're going to be using that power whether the power is going or not. The other item that we use is a branch circuit emergency lighting transfer switch, which I shorten to BTS, basically a branch transfer switch. So this allows normal luminaire function as an emergency lighting without local battery backup. And it receives the emergency power then from your separate emergency source. It allows the luminaire to be dimmed or otherwise controlled with the normal power in the luminaire. And with this one, it can have 0 to 10 volt dimming or line voltage dimming. And I'll show you in this next slide how that works. It turns the luminaire on at full emergency output, whether there is an overall power outage in the facility or the local circuit is tripped. and it receives power from the normal power source until that power is lost. Then it receives it from the emergency. So in my representation here, and again, this is overly simplified, but basically we just have one coil in here now, and then a number of contacts associated with that coil. And so you got your same thing, you got your normal power. And one thing that you'll notice there is that line voltage control. I'm showing a toggle switch, but in the other one, in the ALCR, it drove contact, it drove the coil. But now it's just going through a contact. So if you were doing line voltage dimming, it would be fine with this one, whereas you can't do that with the other one. All right, so let's go through a couple scenarios here. So we've got normal power is present. The normal power switch is closed. That means that the switch power does not energize the coil. Oh, that's what I was saying about you can do line voltage dimming here because you're not energizing a coil. It's just going through this contact. The light's going to be on or controlled via that 0 to 10 voltage control with the other lights. And it's basically powered with normal power. As you can see, it's represented with the blue. Whereas if normal power is lost, then that coil is no longer energized, and the normally closed contacts on that coil then close, and emergency power now feeds our emergency luminaire. So it comes on at full speed and gives us our emergency lighting as needed. So these two devices, we're going to kind of compare them a little bit. The ALCR is rated to UL 924, and it's covered in NEC 700.26. And the BTS is covered by UL 1008, and it's covered in NEC 700.25. So just comparing these quickly. With the ALCR, the luminaire is always fed from the emergency power circuit, whereas with the BTS, it's served from normal power, and the emergency power only feeds it when the normal power is lost. They can be controlled with the other luminaires via a toggle switch or the low voltage dimming. With the BTS, same thing, they're controlled with the other luminaires, but you also have the line voltage dimming capability there. And with the ALCR, when the power is lost, the light comes on at full output, and the same thing with the BTS. So either of these are sufficient. They meet the code. Now, if we go back to what we were looking at in 700.17.2, it says automatically energized either system upon a failure of the other. So you might look at that and say, well, with that ALCR, it's always on the emergency circuit. And so if that circuit was lost, if the breaker tripped or something, then you wouldn't have emergency power. So I guess I'm inclined to maybe prefer the BTS to the ALCR, but like I said, they are both approved by the code, and the ALCR is more common, and they do the job. Okay, so we've talked about how these lights then react to these devices. So now, basically, then the next method using these ALCR or BTS is to have a central inverter system. So it's basically a large battery that's kept charged under normal power conditions. When the normal power is available, then that normal power is simply passed through this inverter and feeds the lights. When the normal power is lost, however, then the inverter converts the battery's DC power to line voltage AC to provide power to the standard light fixtures. And emergency luminaires then are driven to full output via the ALCR or BTS. So then in the NEC, it talks about how we make these systems work. So one way is to have this inverter on the same branch circuit as a normal lighting circuit. That way, if the normal lighting circuit in that area is lost, the inverter comes on and gives us our emergency power. Another way is to have a different branch circuit that requires an ALCR or a BTS. And there's a third way in that paragraph that talks about separate branch circuit from the same panel as the normal lighting circuits. It says the breaker needs to be a lock-on device, and it does not say anything about ALCR or BTS. I don't know how we can do this without an ALCR or a BTS, but it doesn't mention that in the code. So that might get clarified in our next version of it, or maybe there's something I'm not seeing there, how this makes sense, because even if you've got a locked on breaker, it can still trip. There could be a short somewhere and that breaker's going to trip. So I'm not quite sure I understand that one. Like I say, I don't know all this stuff. It's interesting. I love it, but there are still some mysteries to me. Okay, so let's talk about how a central inverter system would work. And in this example here, we've got 3 separate corridors that are egress corridors. Each of them have some emergency lighting, and they're fed by this inverter that is fed by circuit A2, which is a normal power circuit, and feeds the emergency lights in all of these corridors. So let's go through this scenario just to make sure this makes sense. So if all the power goes out in your building, your power is lost, the power on A2 is lost, as well as A4 and A6, your inverter comes on and sends power to the emergency lights in each quarter, because that ALCR then has lost power as well. And it says, hey, we got to have light, and it's going to turn those lights on full power. So that makes sense. Now, what if we just lose circuit A2? We lose circuit A2, then we're going to lose light in that upper corridor, but the ALCR is going to sense that, and it's going to call for power from the inverter. The inverter is going to come on, it's going to produce emergency power. However, in the other 2 corridors, we still have normal power because we just lost that one circuit. For whatever reason, the breaker was turned off. Those ALCRs in those other 2 corridors, they're not going to call for emergency power. So those will still work as normal. So now, what if A6 gets turned off somehow? And so we don't have power on A6. Well, like we talked in the beginning about these inverters, if there is normal power available at A2, it's just going to pass through the inverter to the loads that are connected to it. So even though the inverter itself won't go to battery power, it sees power, and so it's going to continue to send it through to those lights. And in the lower corridor where that ALCR senses that, oh, we've lost normal power, it's going to bring those 2 lights on at their full output. So there are also smaller inverters, and these can mostly cover a single circuit. Some of them have that ALCR function built in, and some can even dim the emergency luminaires, which, if you got a large facility, maybe dimming the luminaires is a better way to make sure that you've got the appropriate lighting levels, and so your battery will last longer because it's not going full output. All right, now let's talk a little bit about generators. So generators are pretty common these days. A lot of people want generators. And we got to talk about, in the NEC, there are 3 sections that deal with these. There's NEC 700, and that's emergency circuits. And it basically, go to that. These are to avoid safety or health hazards egress, panic control, fire pumps, ventilation, they're essential to maintain life, detection, fire alarm systems. And these have to come on within 10 seconds. We also have legally required standby systems in NEC 701. And these are where loss of power can create hazards or hamper rescue of firefighting activities, communications, ventilation, smoke removal, sewer disposal, industrial processes. These need to come on within 60 seconds with an automatic starter and transfer switch. And then we have optional standby systems, as outlined in NEC 702. These could cause discomfort, serious interruption of processes, damage or product or process, but not really life-threatening. And so there's no start time requirement. These could be an automatic transfer switch or a manual transfer switch. And finally, 708 talks about critical operations, power systems or COPS. These are for systems where loss of power could disrupt national security, the economy, public health or safety. And these came into being after some of the major hurricanes that we had. And so these are set up to keep the power going. And these often then will include requirements from NEC 700, 701, and 702, usually a larger system. So it's just a kind of a representation of all the places where we're putting generators these days. A lot of times it's not just for emergency lighting. A lot of times the owner wants or needs backup power for data centers, banks, manufacturing, law enforcement, fire, emergency, detention centers, healthcare, labs, transportation centers, even grocery stores. We're pretty dependent on electrical power these days. And so if we lose it, it's not good. All right, let's talk about some of the requirements then for a generator system that's feeding an emergency system. So first of all, you have to have a permanent means to connect a portable or temporary source to allow for maintenance. And this is just so that when your generator is needing to be maintained, you're not left without anything. You have to have separate emergency transfer switch. You need to have surge protection in each panel board. Your wiring needs to be completely separated from the other wiring in your building. It needs to be located to avoid adverse conditions. Often there are additional fire protection requirements. And finally, the power transfer needs to come on within 10 seconds of an outage. So it's kind of fun to think about how long is 10 seconds? Hopefully I didn't lose any of you there. 10 seconds is a long time. Now, most of these generators will come on quicker than that, but that's the requirement, 10 seconds. And if you're in an area that you're unfamiliar with, it's pretty easy to have and there's no windows or anything, it'd be pretty easy to have the whole panic thing set in. And so that 10 seconds is pretty long. So let's talk a little bit about healthcare facilities. That's a place where generators are often used. And we know that healthcare facilities are covered in NEC 517. And in these systems, they have life safety branch, which is basically our NEC 700, a critical branch, which is our 701, and equipment branch, which would be like your 702, more or less. So the life safety branch, that's covers means of egress and exit signs and things like that. And so those lights need to come on with either your ALCR or your BTS. Whereas your critical branch can include task illumination. And so you would not have the ALCR or BTS because they might need to stay dimmed or off. You might not want the lights to come on bright in some patient's room where it would just agitate them. And so one of the things when you're working with a healthcare system is you got to make sure that your controls, your lighting controls, are on that critical branch. Otherwise, if you leave that on normal power, you might not have the light that you need. Also talking about how the emergency lighting need or emergency circuits need to be completely separated. Up until this last code cycle, basically to do that right out of your generator, you had to come out and have two separate breakers in their own enclosures so that it was completely separated. However, this last code version, this has been addressed, and they can be on the same bus on the generator itself. All right, so let's look at a generator system here. Basically, like we said, the wiring needs to be entirely separated. So you've got a separate transfer switch for your emergency systems, and it's fed by a separate breaker. You've got a manual transfer switch that allows for provision for your portable generator. And then all these things need to be located in a place that will avoid adverse conditions. Also, you'll notice that we've got the surge protective device in our panel. Now, when you look at this, basically, we're backing up the whole system with this generator. And so you've got your lights that are emergency lights, and then you got the rest that's on standby. So they're really both backed up by your generator. And that creates some interesting questions, one of which is if we look at that piece in 700.17.2, it talks about separate and complete systems with independent power sources. So this is one of those things that you might want to talk about with your authority having jurisdiction, and he or she may actually require you to do something like this, to have a normal power for your lighting, and then your emergency lighting would be fed from that normal power that it's not on the generator at all, and on your emergency system panel. It's a judgment call. And like I say, you might want to talk with your authority having jurisdiction just to make sure. Some might say, oh, you're taking that way too far, Garth. But some inspectors might require that. So that's just something to think about. So it's so common for an owner to say, hey, we got this generator. Why do we need battery packs for our lights? That's crazy. We've got a generator. We're going to maintain it. Why would we do that? But in reality, you can't just throw it on any old generator with any old transfer switch. It is an emergency system. And so a lot of times in our firm, we'll just go ahead and put the battery packs, and they may not be on for long. They may, only drive those lights for a few seconds until the generator's up and running. But that way we know we've met the emergency lighting requirements. Okay. So just talking about some of the pros and cons with these different things. I've created a chart here, which I don't expect you to be able to catch all this. We'll send this to you so you can look it over. It's just some thoughts when you're going with these different ways to light, to do your emergency lighting with discrete battery packs, with luminaires, with integral battery pack, with central inverters. One other thing that I didn't talk about with your central inverter, one of the requirements is that you have a way to maintain your emergency system. So really you need to have a way to maintain that central inverter system. And then finally, this goes through some of the, when you use a generator backup for emergency lighting, and you'll note in the considerations, there's a number of requirements that have to be met. And so it's not just a simple thing. All right, went through some of those things pretty quickly. But I appreciate your time, and we'll go back to John.
Okay, thank you, Garth, for that illuminating presentation. I just came up with that, actually.
Yeah.
So once again, thank you all for being here. If you do have any questions, we've got the Q&A panel, and we have maybe 10 minutes. So, Garth, I think there are some questions that come up, and one of them that I've heard you talk about before is, say you're a building owner, and you think, well, wouldn't it just make sense to put all of the lights in the egress corridor on emergency power? What's your response to that?
Well, technically, if you had ALCRs that covered some of those lights, I guess you could, but it's never a good idea because you can't guarantee that your emergency lighting circuit isn't going to have a problem at some point. There have been cases that I've known of in healthcare facilities where a whole wing will be on the life safety branch, and if there's a problem with that panel or something in there, that transfer switch, you can have normal power throughout your facility, but that whole wing is plumb dark. And so you never want that. You always want a mix with basically with outlets too, so that you're never left completely without power if something fails. Because our best laid plans sometimes don't go like we thought.
So maybe build on that a little bit. And, sometimes people would want emergency lighting in a corridor to be controlled by three-way switches, and the NEC 700.20 talks about this. So how do you advise people to think about how to or whether to use three-way switches in an emergency lighting situation?
Now, I'll admit that's one of the pieces in the code that I hope they'll clarify in this next round. Um, what I believe, my understanding of that is it's talking about your emergency feed to those lights. And you don't want that in an area where somebody could inadvertently turn that off. Now, normally you've still got that feed on your lights if you're using the ALCR or your BTS. You've still got that on there. And in fact, we don't usually even put a switch on there. It's just your breaker back in your panel. And then the individuals that use that area, they can switch those lights on and off, because we know that if we ever lose power and we go to emergency power, they are going to come on. But the way it reads, it's a little confusing. It's like saying that you can't have a three-way switch, and yet the code allows us to use the 0 to 10 volt dimming and all the other things. So I really think my feeling on that is that it's saying the actual feed, your actual emergency feed. And if somebody else has a different understanding of that, I'd love to hear about it. Maybe after this webinar, send me an email. I'd love to discuss that, because there's no way I know everything here and wouldn't pretend to. And it just, anything I learn is for the better.
Well, I'll ditto that, Garth. I know that because of the white paper you authored, you have had multiple conversations with folks throughout the weeks leading up to this. And it also makes me recall one of your earlier slides about the code disclaimer. Codes change, they're dynamic. And so perhaps this is an area where you'd want to see the code make some updates.
Yeah. Like I said, I
ahead.
hope they'll make a change, but it would behoove me to write a letter and maybe move a change, ask for a clarification there, and that would help the process along.
Yeah, absolutely. Be the change you want to see, right?
Yeah.
Let me throw one more question out at you, and then I'm going to get to a question just posed in the Q&A here. But this is a situation where exterior lighting egress lighting it's backed up. So does the building owner need to, do the building lights need to come on and stay on for the duration of a power outage, even if the sun is up?
There's a paragraph in there, and I don't have the number in front of me, but it basically says that for egress lighting that is outside, it helps people get to the public way. They do not have to come on when the light when it's bright out. They can be controlled by a photocell or similar. So they would not have to come on and stay on for the 90 minutes if it were light outside. At night, you definitely want them to come on, but if it's during the day, they don't have to.
Very good. Okay. I do think I want to move us on out of respect for people's time and just make a few wrap-up comments here. So let's get to the next slide here. And let me just reiterate a few things. First of all, thank you for joining us, as always. We do provide PDH credits. I want to clarify, we do offer those for non-engineers as well. If you're an architect, an electrical inspector, what have you, that's okay. We need to know your registration requirements, and we can tailor the participation certificate for you. So if you're interested in that, once again, please email us at hello@m-m.net, and we will get out to you. This presentation was recorded, and this is going to be posted to our website. So once again, m-m.net, and on the Insights tab up at the top, you'll have access to this recording, the white paper Garth has issued, and other blogs, insights, and information you might find useful. So with that said, we'd love to stay in touch with you, social media, through our newsletter, get in touch. But until then, thank you all for joining us, and we'll see you on the next one. Thanks so much.